All right, right now I'm going to talk a little bit about mechanical drawing and review some of the things we've talked about, and then talk about a new thing, which is isometric drawing. Okay, so if we look here, we remember that an oblique drawing is simply a front view, and we use a couple different shapes like this, a simple shape that's like a rectangular block with a notch cut out of it. And then I'm going to simply project backwards from the corners of this, approximately on a 30-degree angle. This is going to be the same angle relative to horizontal in all places. And now I'm going to connect these using lines that are parallel to the lines in the front view. Right? Parallel here, parallel there. Because this is a simple shape, this is relatively easy to do. Right? And we would erase away the little excess parts. And there you have the simplest kind of pictorial type drawing. I'll zoom in on it a little bit. Okay, simplest type of pictorial drawing called an oblique drawing. We'll write that here, oblique. Right, which we created by drawing a front view like this and simply projecting back and connecting that up to make this three-dimensional appearance. Right? Now, that's well and good. We're going to go ahead then and go to a more complicated one. And the advantage of the complicated one is that it comes closer to reality, the way it looks, and so it's less distorted. But the disadvantage, of course, is it's a little harder to draw. And we know that the way things look in real life, the closest representation we could have is a perspective drawing, like a two-point perspective or whatever. You think about standing next to a building, you're standing at the corner and you're looking down this way and you're looking down that way, and you can really see as that object recedes further and further into the distance, it appears smaller and smaller. Right? It gets smaller and smaller. Just like if you see somebody, 100 feet away and go like this, that person's probably, this big, right, in your line of sight. So perspective drawing then encourages us to do that. And like the building thing is a classic example of that. Create vanishing points. You have the size here at the front, and it goes towards those vanishing points and gets smaller. This is a little simpler than that. This is called an isometric drawing. The isometric drawing does not start with a front view. What you're going to work from is a single vertical line, and then everything is going to either be vertical, not everything, I'm sorry, everything's going to be based on this axis of vertical and these axes that are, that's not real good, that are 30 degrees from horizontal. Okay, so we're going to go from horizontal up 30 degrees here, like that, and 30 degrees on this side, 30 degrees this side and this side. And all of our features then are going to go along these axes. Some people refer to this as the YY axis, right? And so just to illustrate this here, this is 30 degrees this way, and this one's 30 degrees that way, right? And when you're using drawing tools and stuff, this is not that hard to do because you have that horizontal line created by the T-square, plop down your 30-degree angle triangle on there, and you've got that. So what we start with then in this, and I'm going to position my block so the long way is going on this direction, right here. Okay, I'm going to go out this way and say this is about so many inches this way for this. I'm going to construct it as if it's a solid rectangular prism first, right? And I'll say it's about this wide. So if the length of the block was say 6 inches this way or something like that, you would measure that 6 inches along this axis. Okay, not this way, but along this axis. The vertical measurement would be true right here on this vertical line, and then the other dimension is that way. And we do something like this. And that makes an isometric representation of a rectangular prism, right? We start with that. Now, any of the features that we're going to illustrate here any features beyond the rectangular prism that are in relation to it, though. We say, well, suppose there's a notch cut out here that's half of this dimension, right, and half of the height cut out. We'll go right here at the center and project up here this way, and we'll go at the center here and project down on this view. So it's going this parallel to these axis lines here to make this part, and this is vertical. Now we'll go parallel to these axis lines to go this way, like that, and then finally we connect those up, this 30-degree line here, this vertical line here, right? So far we're getting close. The next thing we need to do then is adjust the camera up a little bit. Sorry about that. Shoot. Okay, so you can see the whole thing. Just a little wider. A little tiny bit wider, huh? Don't want to adjust. There we go. And now I'll take away this excess part from the original prism to just leave the object, right? So if we go like this, and this, and this. And of course, you know, when drawing this on a piece of paper, you'd be doing this with really light construction lines and, and coming back and erasing them later and darkening in the good ones that give you the finished view. Okay? So this is an isometric rendering. Isometric rendering of the same block that I just did in the oblique view. Right? Oblique view, create a front view, project back on the angles. Isometric view, vertical line here, project back 30 degrees this way and 30 degrees this way, and so on. Remove any part here that's not part of the overall prism, and now we've got the object. Of course, this is going to look better when I use some drawing tools to do it and really get these lines, you know, neat and very accurately following those angles as I've specified. Okay, the next thing I want to show you is what you would do if there was a slanted aspect to this block. Right now, all these faces are parallel and perpendicular to the planes of projection, right? So all these lines either are vertical or along 30 degrees this way and 30 degrees this way, right? Now, what if there was a bevel cut off here, say that went from halfway up here to a distance over here, right? It's like a slope surface right there. You might look at the object and say, well, I'll measure the angle of that slope and so on and so forth. But that becomes really difficult to translate that angle into this drawing. It's much easier if, and in this case I'm going to pick an easy version of this instance, of this example, where the lines that establish the slope are part of this, are on these axes, right? So this line here, and then if I make another line here, then the angle that I'm going to create between them is simply defined by finding that if I know that it's a certain distance up to here, say halfway between here and here, is where that bevel intersects this face right here, and I know that it comes up and intersects this face right there, I simply have to connect those two lines carefully to establish that angle in this drawing, right? And then all I would do is, again, erase away the, the lines of the rectangular prism that no longer belong there, right? So if we did like this, and so on, right? Now we've got that same figure that we started with, but now it's got a, a sloped cut off section there. It might be a 45-degree angle in real life, but the way it appears in here is strictly defined by how you find these intersections with the isometric prism, the isometric rectangular prism you drew in the first place. Okay, so that's the way you would do to take this sloped surface and insert it into the isometric drawing. And of course that happens a lot.